Grab your calculator and please do second plus 712. A baseball coach has 500 feet of fencing to enclose 2 rectangular, identically shaped regions for batting cages. Let X represent the width and Y represent the length of one region. We want to express the area of the entire region as a function of X. So we're going to start by drawing a picture here. 2 rectangular regions identically shaped. X represents the width. So I'm going to say that this is the width and Y represents the length. And as we spoke in class, you could choose to say that you view this as the length and this as the width. And as long as you stay consistent, you'll be able to answer the questions below. Express the area of the entire region as a function of X. So expressing the area as a function looks like this. This tells me that when I'm done expressing the function for the area of the entire region, I only want x's on the right-hand side with numbers, not x's and y's. So one of these regions is a rectangle, that's x times y. And I have 2 identical regions, I have a 2 in front. This is a great start, but I need to figure out a way, how do I remove the y? So I'm going to come over here, and I know I have 500 feet of fencing to enclose these 2 regions. So 500 is equal to 1, 2, 3. I have 3 x's plus 1, 2, 3, 4, plus 4 y's. And I'm going to isolate the y. So subtracting 3x to the opposite side, dividing by 4. This is what y is equivalent to. So up here, I have a of x equals 2x times 500, subtract 3x over 4. There's no reason for you to reduce that. Next, we're going to identify the domain of the function. So I've cleared my calculator, and now I'm going to go up to y equals 2x times, and I'm going to put an extra parentheses around this numerator, 500, subtract 3x, divided by 4. Alright, now let's go to Windows. We know that x represents a distance, and distance will always be greater than 0. Alright, so again, let's go back to the domain here. So I can start with 10, that's fine, and let's do a zoom fit, and we're not going to see the entire shape. So I'm going to come back out here, and let's expand this. Let's go up to 50 and do a zoom fit. I want to see this parabola. I want to see it go up, and then actually come down to see. So I went out to 50, not enough. Let's try 100, zoom fit. I'm getting closer. Let's try 200. And that works. Okay, so we can see that 0 is one of the x-intercepts. And let's figure out what this x-intercept is. So second, calculate 0. Now I went all the way out to 200, so I'm going to say 150 and 190. Oops, sorry, I did that wrong. I missed the 9. So let's try this again. 150 is to the left of the x-intercept, 190 is to the right. They're in between those temporary walls, and we can see we have 166 and 2/3, or 166.6 repeating. So when I express the domain of this function, 0 to 166.6 repeating, or 0 to 166 and 2/3. We want to be exact. We don't want to round unless it asks us to. We're not going to include 0. It goes all the way up to this value. Now, I also would accept this. It's greater, x is greater than 0 and less than or equal to 166.6 repeating. Alright, so the next thing we're going to do is we are going to look at our graph, and let's talk about what this means. This horizontal line, the x-axis, is going to represent the value of x, and the corresponding value we get for y on the function will represent the entire area of our enclosed regions. So the next part says find the area when x equals 15. So I can do second trace value, typing in 15. When x equals 15, we can see this is the entire area of their enclosed region. What is the maximum area of the entire region? Second, calculate. maximum. I'm going to choose a value over here like 20. I'm going to choose a value way over here like 170, and then press enter. This is going to be 16.6 repeating. This is going to be the entire maximum area. And lastly, what are the dimensions? What are the dimensions of one rectangular region when you maximize the area? So I'm looking at this right here, and I know that my x when I maximize will be 83.3 repeating. So I find out where x is. This is 83.3 repeating feet. Now how do I figure out the y? There's a couple different ways, but I believe this is what y equals, right? Y equals this. So I think it's easier to take this 83.3 repeating and take 500, subtract 3 times 83.3 repeating, get an answer, pressing enter, and then dividing by 4. So 62.5, and this is 62.5. So 83.3 repeating feet by 62.5 feet.